Electricity in circuits. Cut off the border and cut out every box. All right, electricity. When I say electricity, what do you think of? A light bulb, okay. What else? Okay, stop and think for a moment. Imagine your life without electricity. Ever been camping before? That's probably the closest you've ever gotten, but you still probably had a flashlight. Okay? So, electricity. Amazing, great thing. What is it? It is simply electrons flowing through a material. That's all electricity is. So, electrons, okay? Atoms are made of protons and neutrons and nucleus, the electrons on the outside. Well, the electrons can jump from atom to atom to atom, and when that happens and they all go jumping in the same direction, we have electricity. Okay? Electricity can only flow when there is a complete or unbroken path, which we call a circuit. Okay? There are two different types of circuits, series and parallel. We'll discuss those in detail later. But first, let's talk about that flow of electrons. Electrons can't flow through everything. When they can flow through it, we call it a conductor. Conductor is any material that allows electricity to flow through it. Can anybody give me an example of a conductor? Wire, copper, any metal. Okay? Conductors are usually metals. Now there's one little exception to that rule, and that's water if there are ions dissolved in it. Okay? Water, if there are ions dissolved in it, is good at conducting electricity. Once you've written on it, you can glue it in there on the left. Insulators. Insulators are the opposite. Insulators do not allow electricity to flow through them. Can anybody give me an example of an insulator? Rubber. That's probably the first noticed insulator. Anybody give me another example? Wood. The drier, the better it is. Another example. Any sort of plastic. Have you ever noticed that wire is usually covered in plastic? So you can actually hold, say, a live wire that has electricity running through it, and it will not run through you. It will not shock you. Glass. Electricity cannot flow through glass. And then pure water. If it's just H2O, electricity cannot move through it. Conductors and insulators. You do need to know conductors versus insulators. If it's made of metal, it conducts electricity. Now, some metals are better at conducting than others. Okay? Gold is a really good conductor. Copper is a very good conductor. Not so good conductors, tungsten, not a very good conductor. It conducts, but just not as effectively, not as efficiently. Let's talk about circuits. When we're trying to discuss circuits and explain what they are and understand them, etc., 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 this is what you're probably used to seeing. A battery, a light bulb, a switch. This is a picture of a circuit. However, we don't actually draw circuits that way very often. We usually draw them as a diagram. Okay? So it makes it easier to draw these. So glue these in, but just a little bit of glue, because we're going to write on them. So we have over here the battery. Okay? The battery is the power or energy source. The power source is the battery. Okay? Why do we put okay, the black line here? What's the black line?
The
Wire. Now, why do we put a light bulb in there? Exactly. To know if there's electricity flowing through it. If it was just a wire, a switch, and more wire and a battery, just by looking at it, you could never know if there's actually electricity flowing through it. Does that make sense? By putting the light bulb in there, we can see when electricity is flowing and when it's not. The switch. What does the switch do? It turns the on and off. It is the control. All right? It controls on or off. Now, circuit diagram is designed to make it easier for us to draw. Because I don't know about you, but I'm not the best artist. And drawing a light bulb and a switch and a battery like that every single time is going to be a pain in the butt. So we have this for all of us non-artists out there. Okay, the power source. This is the battery. This little long line, short line, long line, short line, that represents a battery. Okay? The thing that's labeled path here, the line, that's just the wire. Okay, over here, the switch. Okay? If you notice it's positioned like this, that's what we say an open switch. Instead of saying it's on or it's off, we say it's open. Okay? That would be the off position. Because we say it's an open circuit. All right? Load. Put a line through load. Just write light bulb. Okay? There's our light bulb. There's a couple different ways to draw a light bulb. But it's always got a circle on it. Sometimes a circle with an X in it, or a zigzag, or a little loop. But it's always got a circle around it. Okay? That's your light bulb. So the circuit diagram is an easier way for us to draw out a circuit to be able to analyze it than an actual picture. All right, squiggly line. This is where you're going to use your colors. A series circuit has only one path for the electricity to flow. So take one of your colors. We're going to start at one end of the battery. And we're going to follow the wire, what we call the path or the circuit. We're going to go through the light bulb, more wire, through the next light bulb, continue following around, do not lift up your color, and return to the opposite end of the battery. That is a complete circuit. Okay? When the circuit is complete, only then can the electricity flow. Only then do electronics turn on and work. Okay? So in this situation, these light bulbs, because this is a closed circuit, both of these light bulbs have electricity flowing through them and they light up. A parallel circuit, we're going to talk about, has two paths or more for the electricity to flow through. So again, with your color, start at one end of the battery. Follow the circuit, follow the wire, the path. I'm going through the light bulb on top first. And return back to the opposite end of the battery. That is one complete path. Now get your other color. All right, starting again at one end of the battery, follow the path. We are going to now take the path that goes through the lower light bulb and return back to the opposite end of the battery. An unbroken path. We have two unbroken paths. and each of those light bulbs has an unbroken flow of electricity flowing through them, both of these light bulbs are lit up. Does that make sense? Okay, so parallel, two or more paths, series, one path. Now, to be completely honest, series circuits are a little bit easier to analyze, a little bit easier to understand, but they have one great flaw. Little note here. In series circuits, if one bulb burns out, what does that mean for the rest of them? All the bulbs turn off. So I'm going to explain a little bit how that's possible. Okay? Little diagram you do not have to put in your journal. I just want you to have a better understanding. Let's talk about light bulbs. A light bulb. When you envision a light bulb, think more of the traditional light bulbs, not the newer ones. Okay? You probably see something that looks like that. Okay? Now, right here, this is the metal spiral part that screws the light bulb into the socket. Okay? If you ever pay close attention down here at the bottom, there is, like, right here, this part, it's like made of plastic, and then at the very bottom there's a little metal tab right there. Have you ever noticed that? Okay? That's actually pretty important. So let's look at the inside of a light bulb. We have here the filament, and one end of this filament, the wire goes and is soldered to the inside of the part that screws around and screws the light bulb in. This other end goes down to that little dot. And the insulator in between separates the two of those. So when you screw in the light bulb, the electrical current in the circuit goes to this metal, which leads to this wire. The electricity flows here through what's called the filament, comes down and goes down out through the little button at the bottom, and that will go to the other end of your power source. And that's a complete circuit. So the circuit is actually continued inside the light bulb. Okay? When a light bulb burns out, that means the filament literally got so hot after so much use, it breaks. And now the circuit is broken. There's no light because the electricity is no longer flowing. Does that make sense? Okay. So, if one bulb burns out in a series circuit, all of the bulbs will turn off. Parallel circuit. What happens if one bulb burns out? Okay? The other bulbs stay on. And I put that on there, may stay on, because that depends on how they're arranged in their different paths. But they may just stay on. They usually do. That is the purpose for doing parallel circuits. If one bulb burns out, so for example, if the purple light bulb, that filament burns out and breaks, the path of electricity flowing through the pink light bulb continues to flow, and so the pink light bulb stays on, even though the purple light bulb went out. Does that make sense? All right, for how many of you guys is this completely new information? Okay, so you at least seen this before? Good. I like that this is just a recap. Okay, the two little papers we've got left. Take this one. Okay, we have here a picture of a circuit. I want you to take this picture and we are going to turn it into, on the opposite side, a diagram. So going back up here to picture versus diagram, this is a picture. I want us to draw a diagram of that circuit. If you notice here, these are the same thing. We have a power source, we have a switch, and we have a light bulb. These both are the same circuit, one drawn as a picture, one drawn as a diagram. We've got a new picture. I want to see what the diagram looks like. Okay? So first, I always draw my power source. So I'm going to draw a battery. Okay? I'm going to draw a wire coming off of it. Now, what type of circuit do we have here? First of all, what type? Series or parallel? Series. There's only one path there. Okay. So I'm going to draw along here. I'm going to draw a light bulb. Okay. And then a piece of wire and another light bulb. And then the wire returns to the opposite end of the battery. That is our series circuit. Make sense? Easy enough? All right. Go ahead and take that, fold it in half like so. A little bit of glue. Glue it down here below series circuits. What kind of a circuit do we have here? Parallel. We've got how many light bulbs? 3 light bulbs. How many power sources? 1 power source. How many switches? 0 switches. All right? We have a picture. Now we are going to draw its diagram. Okay? So, I'm going to draw my power source. Going to draw a wire. Going to draw my first light bulb. And I'm going to go ahead and finish drawing the path that takes it back to the battery, the power source. But I have three light bulbs. I'm going to draw the next one. I'm going to continue the wire here. Draw another light bulb. And now I'm going to draw the third light bulb. That is a circuit diagram for these 3 light bulbs in parallel. Okay? Once you've done that, go ahead and fold it in half. Glue it in. And that's the notes on electricity and circuits.